Hello everyone. In this session, I am going to discuss about the extended surfaces. They are called as a pins also. And here, about the extended surfaces, I'll discuss the definition, purpose, the types of different pins, applications of the pins. Okay, here we can see the different pins where we are going to apply those extended surfaces. Further, we'll move for taking the definition. Extended surfaces or pins are the slender extensions or protrusions that are attached to the surface of a heat transfer device. Okay, here the extended surface or pins what are there? Those are the extensions or a protrusions those are attached to the surface of the heat transfer device. Then here, why we have to use those extended surfaces or pins? First, we know that heat transfer between the solid surface and a moving fluid is governed by the Newton's law of cooling. So that's Q is equal to HA Ts, the surface temperature, minus of the Ta. There is a Q is the rate of heat transfer, H is the heat transfer coefficient, A is the surface area, and Ts is the surface temperature, and Ta is the ambient or a outside air temperature. Therefore, to increase the convective heat transfer, one can. Here, this is the rate of heat transfer by the convection, which is given by the Newton's law of cooling. And here, if you want to increase the rate of heat transfer by the convection, then one can do that. What we can do? Increase the temperature difference. If you increase this temperature difference, we can increase the rate of heat transfer. Then there is a Ts minus Ta between the surface and the fluid. Secondly, increase the convection coefficient H, increasing of this convection coefficient H. Third one is increase the contact surface area A, increase the contact surface area A. And here, for the fixed temperature difference, that Ts surface temperature is fixed, surrounding the fluid temperature is fixed, then the heat transfer we cannot change by increasing the temperature difference. And this the convection heat transfer coefficient what is there, it depends on the surface and the surrounding fluid. If the surface is fixed, the fluid material, the surface material and the surrounding fluid is velocity is fixed. Okay, if it is a natural convection or a forced convection, its velocity is fixed. Then heat transfer coefficient depend on the velocity and the surface. Those are not changing, therefore we cannot increase the heat transfer coefficient. That is fixed. Therefore, the heat transfer coefficient, how we can increase? Okay, there we can increase the contact surface area A. The contact surface area, that means here the surface area from which heat is transferring, that we have to increase. Here we'll take the example, the electronic circuit surface with pins. Here we can see the electronic boards what are there. There the heat are generating during its operation. The heat generated should be transferred, thereby the cooling should occur. And from this surface, from the its bottom surface, the heat is to be transferred. The commonly that is how this heat transfer is taking place like that. The surface area we are going to use. The surface area we can increase by attaching these extended surfaces. This extended surface will have the more area than the initial area. Therefore, heat transfer rate will be increases by the convection. Thereby, the cooling will be taking place. That is this whatever the use of the extended surface on electronics boards. That is one of the application of the this extended surface. The other applications we'll see. Then, what are the types of pins are there? The pin is one is rectangular pin. The rectangular in size, width, and thickness and length it will be having. Square pin, okay, if the width and thickness are same, then it will become a square pin. Then triangular pin, there's a triangular in cross section. And circular pin, okay, the circular pin is this one. The circular pin can be called as a pin. Okay, the circular pin can be called as a pin. Okay, pin is the another name given to the circular pin. It is a circular in cross sectional, cylindrical cross section it will having. Then that is called as a pin. Okay, just like a pin, the round circular pin, just like it will be its shape is having. That's why it is called as a pin also. The last one, circumferential pin. Along the circumference of the cylinder, the pin's extended surface are used, and that is called as a circumferential pins. Then how this different the types of the pins and different shapes and size we are going to use, and what are the applications, what are the materials we will discuss here. The shape and size of the pins can vary significantly depend on the application and nature of the heat transfer problem. The most commonly used pin geometries are rectangular, triangular, circular, etc. Pins can be made of various materials such as metals, plastics, ceramics, and composites, depending on the operating conditions and the desired properties. Okay, depending on these operating conditions where we are using and depending on the desired properties, we are going to use the different types of the materials. These are the common types of the pins which are used for the increase of the rate of heat transfer. Then further moving here, the process involves transferring the heat from surface to the surrounding fluid through the pin surface, which significantly enhances the rate of heat transfer. Then pins are widely used in various thermal systems, such as air-cooled heat exchangers, refrigeration systems, and electronic cooling devices, radiators, and many more. Air-cooled heat exchangers. Those are air-cooled heat exchangers. Best example is that the two-wheeler internal combustion engines. The two-wheelers, bikes, internal combustion engines. On that, the pins we can see on the internal combustion engines. On the surface, those are pins we can see. Those are the air-cooled heat exchangers. By the air only, the cooling will be taking place. Thereby, heat exchange taking place. Refrigeration systems. Refrigeration system here, the heat we have to absorb from the refrigeration cabinet, and that should be rejected to the outside atmosphere or in a room, and there we are going to use the whatever this uh, cooling tubes are there. Okay, that is condenser tubes, and there the heat will be transferring to the surrounding air. There the pins are attached to the tubes in order to increase the more surface area, and thereby the heat transfer rate will be increases. Electronic cooling devices. The electronic cooling devices, we can see, even though providing the this cooling fans, we are going to use the pins over there. Already we have discussed about the this fan and the pins what we are going to use on the electronic boards and devices. And the radiators. These are the radiators which are used in the uh, vehicles. Okay, not to cool, that is whatever the coolant oil is there. The in the heavy engines, the whatever the engine surface is there. Okay, there is a cylinder head and the cylinder surfaces. So those are having the higher temperature during the combustion, and those are to be cooled. And there the coolant is circulated. The cooling oil will be circulated, and that will be get heated, and that its heat will be transferred through the radiator to the surrounding air, and that is the whatever the radiator we are going to use, and many more applications we are going to use. As earlier in the first slide we have seen the electrical motor, transformers. Okay, these are also a common applications where we are going to use the pins for the transfer of the heats. The primary purpose of using pins is to increase the surface area of the heat transfer device and thereby improve its heat transfer rate. That is the primary function of the pins. And the pins for that, whatever the temperature distribution is there as well as the rate of heat transfer is there, that we have to determine, and for that we are going to develop the expression or a equation, and that I am going to continue in the next session. And thanks for watching. If you like, share, subscribe, and comment.